Hey guys, I'm still on section 4.5. This is page 393, and now we're going to switch gears again. So we've talked about how to solve systems by using graphing, but I also want to show you an algebraic way that you can do this. And I'm just going to show you the elimination method. So you might remember having learned like substitution and elimination, but we're just going to use elimination in this course just because it will work. So here is kind of the classic elimination problem, just to kind of illustrate the idea behind this. So check this out. 3x minus y equals 8 and 2x plus y equals -3. The thing I want you to notice with this are how these y's look. Notice how there's this minus y and this plus y. This is kind of the goal with elimination, is to have this type of relationship where you have like almost opposite variables. So when this happens, and sometimes it'll just be given to you, so this is ideal, then what you do basically is you add the equations straight down. So I'm going to put a line here, and I'm just going to note, so add together. So let's go through this. I have 2x plus 3x. This will give me 5x. The y's drop out, so I'm actually not going to write anything for them. And then this 8 minus this 3, what does this equal? This equals 5. So after you are able to add these together, then what you want to do is you want to solve for the remaining variable. So you guys know how to do that, so we can just go ahead and divide both sides by 5, so I get x equals 1. And now what we're going to do is we still have another letter to solve for. So now we plug this into one of the other equations to solve for the other letter. Okay, so I'm just going to choose, it doesn't matter which one you choose, I'm just going to choose the second one because it just has more positive things on one side. That's really the only reason. So I'm going to use this 2x plus y equals -3. So like I said, I'm going to plug in now the 1 for the x, and so now you can see that you can solve for the y. So this really just becomes 2 plus y equals -3, and then I subtract 2 from each side, so I get y equals -5. So then you just want to state what is your solution. So in this case, my solution would be the ordered pair 1, -5. And you can check that by plugging it back in. So this is kind of the ideal scenario where a letter just drops out. But I also want to show you the other side of this, where it's maybe just a little more tricky. So now look at this example. So now I don't have that nice relationship that I want. So then what you do for elimination is you can actually manipulate one of the equations to make it do what you want. So in looking at this, I want to multiply one equation by one number. That's ideally what I would like to do. You can't always do that. But in looking at this, so notice that if I just multiplied this equation by 3, that would at least get me a -6y, but this is -6y and -6y. So actually, if I multiply this entire equation by -3, this would get me a relationship between the y's. So what you're looking for is that kind of relationship. Is there something you can multiply by that would help you just easily cancel out one of the letters? And it doesn't matter what letter it is. It can be x or it can be y. So you just have to look for the kind of the path of least resistance. So in this case, what I want to do, I want to multiply this by 3. So let's do that. So let's see, multiply by 3. So let's go through and actually figure out what would happen if I multiply each one of these by 3. This would become, so I'm going to write it over here, 15x, multiplied by -3, my bad. So this would be -15x plus 6y equals 12. So I went through and I multiplied all of this together. And now that I've done that, I want to restate the system. So let's do that. I've got 3x minus 6y equals 12. And then I've got negative 15x plus 6y also equals 12. Okay, so now I have that relationship that I'm looking for, right? I have negative and positive, so I can just add these straight down. So what I want you to do is I want you to go ahead and add the two systems together and see if you can solve for one letter and then try to solve for the other one. So basically finish the problem. Hit play when you're ready. Okay, so if I add these straight down, so I get negative 12x equals 24 because negative 6 and positive 6, those canceled out. So now if I divide all sides by negative 12, I get x equals negative 2. Okay, cool. So now what I can do is I can plug this back into one of my original equations. Again, it doesn't matter which one you want to do. I'm just going to plug it into the first one. So I'm going to take my 3x minus 6y equals 12, and now I'm going to plug in x equals negative 2. Okay, so here I go. And now I just have to go through and solve for it. So this becomes negative 6 minus 6y equals 12. I'll add 6 to each side. I get negative 6y equals 18. I divide all sides by negative 6 and I get y equals negative 3. So therefore, my solution in this case, make sure you always state it, this will be negative 2, negative 3. So there's kind of the idea behind this. So now what I want you guys to do is I want you to try this. So this first one's already like kind of nice and set up for you. So go ahead and try to solve this first one. Hit play when you're ready to see the solution. So this one's all ready to go, so I can actually just go ahead and add straight down. So I'm just going to put a line right here, and this becomes really 7x equals 0. So if I divide both sides by 7, I'll get x equals 0, because 0 can totally be in the top. And now I'll just plug this back into either one of the equations. So I'm going to plug it into the first equation. So I get this, 4 times 0 plus 2y equals negative 6. So I get 2y equals negative 6. Divide both sides by 2 and you get y equals negative 3. So my solution will be 0, negative 3. Okay, so now for B, you can see that you're going to have to multiply one of these equations by something. So that can be done in just one move. So try to choose the optimal equation and see if you can see this the rest of the way through and hit play when you're ready to see the solution. So what you're going to want to do here is you're going to want to multiply this equation by negative 2. So I want to actually write out what that is before I go any farther, and then I'll restate the system. So this will be negative 2x plus 6y equals negative 10. So now I need to restate the system. You want to do that just to keep things neat and clean. This is kind of the one of the key parts of this is you've got to keep everything neat or you're going to get lost in your work. So there's the equation I just recreated, and then I've got 2x minus 5y equals 3. And now I've got that relationship that I'm looking for where they're the negatives. So I can add straight down. This one actually works out really nicely because I don't even have to do anything else to solve for y. So I just get y equals negative 7. Now I'm going to plug that back in. So I'm going to plug this into the first equation. So I've got y minus 3 times negative 7 equals 5. So this becomes y plus 21 equals 5. Subtract the 21 from each side. And I get x equals negative 16. So my solution in this case is negative 16, negative 7. Okay, so now for this last one, this is like kind of a tricky one. So in this particular example, you actually cannot just do one multiplication. You're going to have to multiply both. So in looking at this, I'll kind of start this with you. So I would try to choose numbers that are lower. So like technically you can really multiply whatever you want, but I would like to drop out these x's. So I'm going to multiply the top equation by negative 2. So I'll note that first. So I'll give myself some room. Multiply by negative 2. And then this other equation, I'm going to multiply this by positive 5. So it's just dependent on the problem whether or not you have to do this. So you just kind of watch out for it. So I'm just going to go ahead and do everything in one sweep. So first let's start by multiplying this top equation by negative 2. So 5 times negative 2 is negative 10x. Negative 10y times negative 2 will give me 20y. And then 5 times negative 2 will give me negative 10. So there's my first one. So now let's work on the second one. 2x times 5 will give me 10x. Negative 3y times 5 will give me negative 15y. And then 6 times 5 will give me 30. And so now I'm back in business, right? So now I can add straight down. So this will become 5y equals 20. Divide both sides by 5, and I get y equals 4. So now I want to plug that back into one of the original equations. I'll plug it into the second equation. So this will be 2x minus 3 times 4 equals 6. So this is 2x minus 12 equals 6. Add the 12 to both sides, so I get 2x equals 18. Divide both sides by 2, and I get x equals 9. And so then my solution will be 9. Give myself a little more space than that. My solution will be 9, 4. Okay, so there's two more I want to go through in this part of the video. So I want to just talk about what happens when we have infinite solution or no solution. And this shouldn't say with substitution, it should just say with elimination, sorry. Okay, so what we're going to do is we're going to do the exact same thing we've been doing before. So just look at this equation. So what would be the best thing to multiply by? I want to multiply the top equation by 2. So let me just note that. So I'm going to multiply this by 2. So if I do that, I get 10x minus 4y equals 2. So let me restack that whole system. So I get 10x minus 4y equals 2. And then I have the bottom one, negative 10x plus 4y equals 3. So look at what happens when you try to add these equations up. The x's drop out and the y's drop out. Now, don't just leave nothing there. You need a placeholder since the whole side dropped out. So put a 0 as a placeholder. So this will say 0 equals 5. And we know how to interpret this, right? This means no solution. So there it is. Okay, so now taking a look at b, so what would I want to multiply? I've got 3x plus y equals 5 and negative 9x minus 3y equals negative 15. So in looking at this, you can probably tell that you want to multiply this one by 3. And so I'll just write out what that comes out to. So 3x times 3 is 9x, 3 times y is going to give me 3y, and then 5 times 3 is going to give me 15. And here's the second equation. And so if I try to now add everything together, so now both sides of the equation actually fall out, but I get something that's true, right? 0 equals 0 is true. So we know the interpretation of this, it's infinite solutions. Or if you want to make the fancy R, you can make the fancy R, you do you. Okay, so that's one part of this. So the other part of this lesson, or the last part really, is we just want to talk about just a few other of our favorite situations. So we have one more part after this. I'll see you in the next one.